We can look at equivalent fractions as equivalent proportions or equivalent ratios. And these things are the same based on a proportion. So it's basically times and divide. Okay. So we have 3/4 here. So I can divide this up into 3 equal parts. So 3 parts out of 4 parts whole. And we can make an equivalent fraction. Now equivalent fractions can look at it as a proportion, as a ratio. We can also think of it as a fraction as a number on a number line. Okay, so if I write that position as 3/4 on a number line and that as 4 on a number line, as 0 on the number line, the equivalent fraction should end up in the same spot. Okay, but we need to write it into different proportions. So we can use a multiplier here. For example, we can do times 2 times 2, and we can say that 3 parts out of 4 is the same as 6 parts out of 8. And that times 2, remember, is multiplication is grouping. So I can do groups of 2. And when I do that, I have 1, 2, 3, 4, 5, 6 parts that I'm going to shade, and 8 parts that make the whole. And that as long as we keep the same proportion and we keep the same multiplier on top and bottom, we're going to have the same number of groups of parts and wholes, and that ratio stays the same, which keeps it the same number. Okay, so we can do this in 3 parts, in groups of 3. We can say 9 out of 12 parts. So we can have our original 3/4 again. We know it's going to end up here. But now we're going to do these parts into groups of 3. Okay, so that times 3 means groups of 3. So we can do a group of 3 here, a group of 3 here, a group of 3 here, and a group of 3 here. That's going to give me 12 parts whole. And the number of parts I'm going to shade are going to be 3 groups of 3, which is 9 parts. Okay, so those 9 parts out of 12 represent the same 3/4 fraction. Okay, so we can think of why they're equivalent. Well, some reasons why they're equivalent. There's many reasons. One, the numbers are the same. Okay, so we can say that the number is the same on the number line. Okay, so that's one way we can say they're the same. We can say that the whole part ratio, or the part whole ratio, we'll say, the part to whole ratio is the same proportion. That's an important word, proportion. Okay. We can also say that when we divide the two numbers, we get the same decimal. Okay, when we divide, so this. Okay, we get the same decimal. So there's lots of reasons why these fractions are all equivalent fractions. Okay, so we can draw divisions on the number line as well. So if we have, okay, this is 2/3, we can draw it as 2 parts out of 3 on the number line. Okay, we can draw the same thing. We can divide this into groups of 2. Okay, and that factor is going to be really important. Okay, so I can do this groups of 3, or 3 parts, into groups of 2. Okay, so I can do all groups of 2, and then we can say that the same proportion of 4 parts out of, so I'm going to write this as 4 out of 6. So 4 parts out of 6 is going to get us the same point on the number line. Okay, so that's going to be 4 parts out of 6 is going to give us the same point on the number line as 3 parts out of 2. And so in fact we can show equivalent fraction parts all on there. Okay, and we can do the same thing. We can do, times 3 times 3, and we can do in 3 divisions. Okay, so here we have our divisions of 3 or thirds, and then we can do this in groups of 3. So we can divide this into groups of 3, groups of 3, groups of 3. So we're going to increase the parts by 3 times and the number of parts that make the whole by 3 times. And so we're going to end up with 6 parts out of 9 parts whole. And again, if I draw my vector here, okay, so that part, if I count it up, that's going to be 3 parts out of 9. This is going to be 6 parts out of 9, and that's equivalent to 2/3 and to 4 out of 6.